probably put my head up and say, we're one of the few companies which use data at all facets of running a business. As a data scientist, you drill, so which means you help us understand what is the best way of solving a particular problem at hand.
Hello everyone, welcome back to yet another episode of The Data Show. And this time around, I have a special guest from the team Rapido. Now, Rapido is an Indian online bike taxi aggregator based out of Bangalore. Now, the company was founded in 2015, and since then, they are now operating in over 100 cities across the country. Now, Rapido has been incorporating data science across every aspect of their product, be it reducing cost, optimizing their dispatch algorithm, or enhancing the product interface in general. Now, they are running over 20 data experiments in a week. And how do they pull this off? To discuss this, I have Pramod with me today, who is heading the data science team at Rapido. Now, our conversation covers a wide range of topics. We have discussed from responsibilities of data scientists at Rapido to their hiring philosophy to their design, basically their experiment design philosophy, and how they have been able to put together such a passionate team of data scientists. So here's the conversation that we had, and I hope you guys enjoy it.
So, hello, Pramod. Again, I know you're a busy man, and thanks for taking out the time to meet today. And I'm really excited to have you here and talk about the rise of applied data science, and especially how Rapido is advancing in this direction, and how you guys are, applying data science, incorporating those statistical experiments to enhance your product in general. So, to start off, I would like to hear your take on data science, as it is such a broad field in itself, and there are so many notions around it. So, what does data science mean at Rapido?
I think it's a very, again, broad question. So fundamentally for us, the vision for us is to be data-driven at all avenues possible from a business point of view, right? And I could probably put my head up and say, we're one of the few companies which use data at all facets of running a business. We're a very metrics-driven sort of a company, and so on. It's a metrics-driven culture, and in that kind of an organizational setup, data science essentially means being able to foresee. Firstly, while we look at metrics as and when we get it, being able to foresee and being able to see what might happen in the future is something that data science would contribute to. It is also being able to see we are not leaving anything unoptimized, right? Not leaving money on the table, not wasting where we're not supposed to waste. Being able to utilize our captain force in the best possible way, being able to maximize earnings for them, being able to give better rides for our customers at a better price, and so on and so forth. Right. So data science essentially is there is an organizational setup and a culture of looking at metrics, and there are people who look at this at a daily, hourly basis. Data science is almost like giving rocket fuel to that process, right? And it's simply, there is no other fancy anything going on, right? How do we enable these people to become better and make the business more efficient and provide better experience?
Now, be it machine learning or simply just core statistical experiments, it doesn't matter, right?
So I think one of the, I think this is I would call it a philosophical stance that we have taken essentially, right? Where we're not AI hungry, right? While we will silently use AI, right? So we don't want to be harping on the biggest and the fattest algorithm, but we would want to be using the right tool for the right job wherever possible, right? So it doesn't matter whether there's a simple probability calculation to like a deep learning model running somewhere, or there are ensemble of different learning algorithms working together to give something. It doesn't matter. I think for us, what matters is we are slightly tool agnostic, slightly algorithm agnostic. So again, the biggest gun does not give you the better result. I think you almost like snipers, right? So even with one more targeted, solving the problem is what is more core and more focused than like using the biggest to the best algorithm.
And that's well put, the sniper analogy. Great. And so what are the day-to-day responsibilities of a data analyst or a data scientist who is working at Rapido?
Right. So I think there is a bit of background on team structure, which changes the narrative slightly, not a lot, but right. So, and I talk about this constantly everywhere. Like, so we have three legs in a product, and a lot of wings and arms. We'll talk about the wings and arms later, maybe. The three legs essentially are it's almost like it's one entity, but they have to be played by three people because of the skill sets and what they bring to the table, etc. And the metaphor that I would use to describe this is that of a tunnel boring machine. I don't know if you've heard of a tunnel boring machine. TBM, the things that are drilling metros and other kinds of projects around the world, right? So there are fundamentally three aspects of this TBM of the machine. There is a drill bit, which is the front, which leads. It's like a massive turning thing that chugs out mountains and whatever granite in Bangalore or whatever. Right? And then there is the navigation, where when you're underground and you're blind, you need to be still able to see through rock. Whether there is a cavity, whether there is harder rock ahead, whether there's water, whatever the reason. And the third thing is the conveyor, the arrangement section, which is to ensure you're able to force. Right? So our data science team essentially works like a TBM, right? So if there's a product and a goal for the product almost acts like the navigational piece of the entire thing, right? Where as a product owner or a product manager, you are sort of constantly saying, okay, drill here, drill there. There's more value there. There's a cavity there. That's a catch. We should not go there or whatever. Right? And as a data scientist, you're the drill bit, right? Where you are facing the hardest of the problems, right? And you are facing the worst of the brunt, right? So you will face the hardest of the rock or the softest of the cavity. But the expectation from you is you help us push through and drill no matter what, right? And we'll talk a bit about like, what does that mean in a bit. And the third part, where like our analysts act like the conveyors, where they ensure that once it is drilled, stuff just just so that you know.
So this I'll cut out, so you don't have to worry about this.
Okay, cool. So I was just saying the third aspect of that three-legged machine is the arrangement and making sure that after we've drilled, that structure behind this doesn't fall, right? So our analysts sort of act like a reinforcement to the entire system, right? Where they make sure we are able to run repeatable experiments. They're fundamental part of every experiment cycle, tracking all kinds of metrics, ensuring they're able to narrate a story of what is happening in an experiment, right? So those are the three legs of the journey. I think your question was, what does it mean to be a data analyst and a data scientist? The answer simply is, as a data scientist, you drill, so which means you help us understand what is the best way of solving a particular problem at hand, whether it is pricing optimization around that, or dispatch, and how do we match, or how do you give discounts to the right people, how do you provide a better sort of customer experience because of some of the campaigns that we run, or whatever be the case, right? So that would be as a data scientist. And as an analyst, your fundamental responsibility is to ensure we are able to run experiments, track experiments. We are able to find problems with experiments and solve for them. We're able to sort of see where we are going wrong and where we are going right, double down on places where we're going right, stop or pause on places where we're going wrong. More importantly, you're able to tell a story of how an experiment is going, right? So, for example, if we say, like one of the most famous examples in the mobility industry is that of search, right? So ravingly talk about how Uber did search pricing and how it helped them during their peak performance and stuff like that, right? Now, one of the, like, if you just pick that example, as a data scientist, your responsibility is to find the parts of the problem, which with the help of the product person, and try and address the part of the problem. Like, for example, peak hours, we're getting too much demand and we have supply. What do we do, right? And then solve for that through experiments, right? So whether it is trying out different algorithms, trying out different hypotheses within an algorithm, or whatever be the case. Now, as an analyst, the responsibility is to sort of ensure every experiment that we pick has a certain business prior. We know what was going on before. We're able to track. We're able to tell a story of how the marketplace was behaving back then, right? And then there is the conception of the experiment. You'll work with the data scientists to figure out how do we conceive this? Is it going to be A/B? Is it going to be multi-arm bandit, or is it going to be ABC, or whatever be the case, right? And then post the conception, you will help set up and track how is the experiment performing? Should we cut it now? Should we run it longer? Is it conclusive? Should we run any kind of statistical test to verify whatever is required to sort of conclude the experiment? Right? So that's broadly how I would say the three roles work. More importantly, the two roles of the data scientist and a data analyst work together.
Okay, great. You have quite a framework there that I have come across for the first time, and the whole drilling experiment that you talked about. This is interesting how you explain it. So I was so I was reading your recent blog on how you guys are designing data experiments to optimize the right dispatch algorithm and reducing costs and the product in general. So if you could first give us some context on how the Rapido right dispatch algorithm, how it works, and then how did you go about designing this experiment?
Right. So just to give you a bit of context, like some of this is quite proprietary, but some of this is quite open. Right?
Okay.
I'll try and avoid what is experimental and what is sort of the secret sauce, if I were to call it so. But most of the stuff I can talk about. Now, typically, if you look at any on-demand rides kind of a market, whether it is a delivery or otherwise, one of the things that happens is you request a ride on your phone, right? And you will be assigned a captain or a driver.
Yeah.
And then, the rest of the stuff happens. The driver comes to your place, you get on the bike or get on the car or whatever, and then you go somewhere else, stops. This entire process is what is the boundary of dispatch, right?
Okay.
Now, what used to happen earlier, prior to like us intervening from a data point, etc., was this is a 5 years old system almost, and it used to do a very rudimentary form of dispatch, where for every request that I create, it's almost like there is an imaginary radius around me of let's say 1, 2, or over many kilometers, right? And whichever captain is in that radius, you will start picking them. Are you interested in this order? Are you interested in this order? Like roughly, that's what you. So there are certain issues with such a like a methodology of dispatch, right? One is yes, it happens one after another. We'll come to that if we come to that. The other is the radius. Every time you draw this radius, it's fairly unique for a person simply because it is radius around a lat long, right? So what that means is just from a sourcing of who do you take a ride with, uh, that becomes slightly less predictable, right? So if you're just a few meters away from this arbitrary dispatch radius, you probably are not part of the like the dispatch queue, if I were to call it. So and these things make the marketplace slightly more inefficient, right? So because everyone gets a new radius, sometimes the radius has lakes as half the half of the circle is lake, right? What do you do then? Right? So then, from a marketplace point of view, it's very inefficient. So our first step in changing this was to ensure we don't just draw arbitrary radius. We make the entire marketplace slightly more discrete and more predictable, right? So what do I mean by that? So currently, if you see, I don't know if you've worked with Uber's H3 library and what Uber did to solve very similar problems, and they've open sourced this library, and it's a fabulous piece of engineering, just from a thinking and how it is architected point of view. Right? So as a first step, one of the first things that we have done is to adopt very similar thinking as to how we will look at geo, how we divide geo. So currently, by doing this, point and radius and so on, we almost made geography as a continuous space, right? Like every point is new, every point is has less order and has no way of folding and no way of grouping and so on and so forth. So which made us gain any efficiency sort of slightly harder, right? So the first step was to make that more discrete. So what do I mean by that? We use the H3 concept or the hexes concept to sort of discretize our geo, where now it's not a radius around every person, but it's almost like a radius around a fixed geography, right? So as a consequence, what you do because of this is you can eliminate things that are like lakes and that are military areas and so on and so forth, which you will never even consider to be part of sourcing or dispatch, right? So just a very small example of like the first most like smallest. Can you hear me now? Is this any better?
Yeah, it's fine.
Okay, sure. What was I saying? Yeah, so I was saying this is an example of a very small change which brought about a lot more efficiency in the marketplace than before, right? So what this has allowed us to do is to like do a lot more experiments on how we source, how we uh, group geo, and how we manage supply demand levels purely by managing the adjacencies of these hexes, right? So the experiments have primarily been how to go about grouping, how to go about sourcing, when do we do what kind of sourcing, when do we do what kind of grouping, should we be predicting at a hex level, should we be predicting at some other level. Some of those decisions is why we're doing a lot of these experiments. The primary goal of these experiments is to reduce ETS, right? So from a customer point, what we don't want our customers to do is wait eternally, right? In the pursuit of reducing ETS, we are trying out a lot of these experiments. And the second part of this is to sort of reduce a burden on our captains, where if there is a dispatch and let's say people are far away, they have to travel longer to pick up someone, right? So it becomes harder and it's more of a burden on their pocket. right? So the ultimate goal of this dispatch has been to sort of solve for these problems, these higher order goals, which are reduce ETA, improve earnings from a capital point of view, and that as a consequence, like these things should happen as a consequence of better matching, right? So that's what dispatch experiments are all about. And I think in the blog you saw just one example where we were, if we replace some hex with another because of driving and so on, like you will gain some efficiency. I think that's just one example of what is going on.
Mm-hmm. Yeah. So also, what were the challenges while you were designing these experiments or running these experiments?
One of the primary challenges, it's hard to do test and control. Like it's hard to do A/B or anything, right? Simply because these geographies are not homogeneous, and it's hard to define homogeneity of geography. What is similar, what is not. Defining test group and control group, which are not at a people level, which are fairly discrete, is one of the fundamental challenge, right? So how do you make sure that something that is less controllable become more controllable? I think that's the biggest challenge of setting up these experiments. And I think in the blog we talk about one such example of how we came up with some of the parameters which define geography, where we were able to see some geographies as being similar from a need point of view versus others. And that allowed us to sort of separate slightly more cleanly, who is taking ride, why are they taking ride. More importantly, why are they taking ride than who's taking ride.
Okay.
Right. So I think that's the biggest challenge with running dispatch experiments.
So does it also include like what time of day it is, and based on that you decide like who will be exposed to what sort of experiment or what sort of trial?
Yeah, I think most of the problems in a marketplace kind of a setup is always geotemporal in our case, right? Mm-hmm. When I say geotemporal, it is a combination of geography, location, as well as combination of time. So morning peaks are not the same as evening peaks. Afternoon peaks are different, night is different, and so on and so forth, right? So very similarly, the same location, let's say, is a very hot demand center in the morning, but might not be a demand center in the evening, right? So it's definitely a geotemporal, like a kind of an experiment setup for sure.
Mm-hmm. Okay. So, like, as you know, we are undergoing these crises, and I want to know, like, what did you guys do when the entire world was under lockdown, and Rapido must have not had any business back then with no rights, and how did your goals or your vision change at that point of time, if at all they changed?
So I think just from a vision point of view, like as a company, we are here to move and solve movement problem for India, right? So bike taxi is one of such examples. I think now we've started doing auto. We've been in the delivery support sort of like logistics support sort of a business anyway. So I think movement, anything that we move, I think we've also launched a couple of other products, but anything which involves movement, we want to be able to sort of contribute, right? So because India has a lot of opportunities purely from like transportation movement of people or goods point of view. Our current focus has been to do all of this hyperlocal, right? And we will continue to keep this. So which if you see, in the lockdown, what we have done is we launched 3 new products or offerings. One of them was a courier offering where during lockdown, if people wanted to send stuff to each other, they could do that, which was again aligned to the vision of, we want to move people or things in India. Again, we launched another product on auto, which was again aligned to the very similar sort of a vision. We launched another product on groceries, but not like everyone else is doing. I think ours is slightly more nimble and more niche, I would say, because again, believe in a fundamental evolution. Like we need to build it in bits, not do big bang products or whatever. So which means like the message is in the past 6 months, while we have been worried about like the situation and what is going on, etc., we've always also been fairly more focused. Okay, what do we really want to achieve? How do we want to get there? Like should we just completely take a U-turn? Should we do something else? Like what is that? And I think the answer has emerged, at least as a leadership team. Like all of us go through this, what we're seeing unanimously across the board is that we want to head more closer to our vision and build so that when things are slightly more normal, we'll be able to execute better as well as solve for problems right now. Like I think a lot of people asked for slightly more safer way of doing travel, so we've launched an initiative on the Shield. I don't think anybody else in India is doing that. And so on and so forth, right? So I think while we focus on the current need, we always have the view of the future of where we want to be, what we want to achieve, and I think that's what has happened in the past 6 months, right? So this is purely from a business point of view.
Yeah.
If you look at other things, I think one of the stance that we've taken is we will not randomly fire. Right? We built a very interesting team.
Yeah.
It has taken us long time to build that team, right? So we've unnecessarily not let go of anyone. Right?
Okay, that's interesting.
And the focus has been to make sure that we double down on the team, we get more out of the team. Putting together intelligent people and then saying, you know what, now it's not required, it's probably not as ideal as we'd expect it to be, and hence we sort of said, okay, we'll not get rid of, but instead we will double down and we'll do more. Right.
Okay.
So I think that is another people change that has happened over the past 6 months. And finally, I think what it is giving us is a conviction that if we ride this wave, while it is a lower slope and it's a harder situation to be and so on, it has given us more conviction that look, this lot more is possible. When we were growing at a certain rate, and then we had to suddenly, like there was a cliff and we had to stop. Now I think we are almost in the middle of the cliff. I don't know if we're done with this yet. And now we have the conviction that okay, we can face this even stronger. And we're hoping for our next quarter to be slightly more better. So yeah, in a nutshell, I think so I think in a nutshell, I think we launched a lot of products. We worked with a lot of government agencies in the lockdown and did some social good there. And now we're looking forward to sort of doubling down and expanding rapidly what we were doing at that.
Okay. That's interesting about the letting go. Well, there were people being fired. So as you know, there are 5 million jobs that were gone and in the organized sector, and there'll be many. The number is just very low. Very small number for what the ground reality is. So yeah, great. And so is there a data science philosophy, the team philosophy that you guys follow within the team? Like this is what the data science team is for, or like the mission statement or something like that drives the team?
Mission, I think mission statements are for a mission. Like I think our mission is endless.
Okay.
The way we would put it is the biggest data science philosophy for us is experiment. Like if you want to call that as a motto, mission statement, sure. So right. So which means we will never sit in a corner, build a model, and be happy about it. Like that's nonsense, right? I think for us, in fact, like some of the measures and some of the products is the number of experiments we do, right? Like how many experiments are we running? And how are we able to conclude experiments, whether it is success or failure? I think that is a measure for, like, it's almost there for some people, right? So I think I would say that is the most underlying philosophy of what we are trying to achieve, which is learn through experiments, do it faster, fail faster, don't model for the sake of modeling, and experiment driven is probably one of the ways of putting that.
Yeah. Okay. Interesting. Now I get that you have or have been working on a lot of different kinds of problems and using data to solve them, but like I'm sure not all of them would have been successful in the first go. So can you walk us through like one of the failures that your team didn't see coming, like except the COVID thing that no one saw coming?
Right. So I think failures, we have failures on a daily basis, right?
Okay.
And I think the part of experiment is to embrace failure and avoid failures, right? So experiment essentially means you don't know what is going to happen.
Yeah.
I'm okay with either success or failure. I will get the learning what works, what doesn't work, right? So which means if we have taken an experiment first approach, it's not like all experiments always succeed, right? So like a lot of experiments fail, and that is part of the job, and we don't even look at it as like a setback, because at least we now know that it doesn't work, right? So there's no point fretting about not making it work. We pick up another thing, move on. The reason why we're able to do that is twofold. One is we ensure that the running of experiment is cheaper. Like there is a constant focus on you have to constantly run cheaper experiments. The more costlier the experiment there is, the failures become costly, right? So the only way of sort of getting around failure is to reduce the cost of failure, right? So if the failure cost is very low, how does it win, right? So I think that's given that kind of a approach and a philosophy. I think we fail very frequently, and more frequently than a lot of people can imagine. Like if we run an experiment a week, I'm pretty sure there is a failure every week, right? Because we are able to control the size of failure and the cost of failure. It does not impact as much and is not like a massive setback, right? So just one of the examples was we ran back in Feb. We had a certain hypothesis of how to identify segments and stuff like that. I think at some point we were running 20 experiments a week, right? Just on that product line, right? And I think one of our data scientists said, actually, this is not working because we're not finding statistical significance, right? And we had to discard like a few weeks of experiments as a consequence. But we already had an alternative because we knew what was not working, right? And these things constantly happen, right? Because we had an alternative, we knew what was not working. The experiments were run clean, etc. Tweaking and changing became very easy. In fact, that led to one of the optimization solutions that we built on how to invest in our customers and campaigns, right? I don't think if we had gone through that cycle, we would have reached that optimization sort of a phase, right? So I think, if this was an advice to a lot of data science people out there, I think my suggestion would be just reduce the cost of your experiment, make your experiments cheaper, fail more so that you're able to fail cheap rather than waiting eternally finessing the model or whatever. That philosophy has helped us sort of avoid a lot of setbacks. Even the setback that I was talking about is just it's a matter of a couple of weeks of effort, and we were able to pick it up and run again, right? And we were able to run faster than what it took us to get to, right?
And does it include the time window as well, the experiment? Like, should it be like, let's say I would run this experiment for just 4 weeks or 6 weeks. So should it be like the time window should be shorter, longer, or is there any take on that? Like I know that statistical experiments should be kept for a short window of time, but again, I don't want to put a number on there because that's not correct, and the reality is more nuanced, and it depends a lot on the problem statement and what you are about to your hypothesis, basically.
Yeah, I think you're right. Like there is a general guideline of smell of running a bad experiment. But we don't prescribe what should be the schedule duration.
Yeah.
So I think there are a lot of online calculators as to how much longer, like what should be the size of the sample and the duration of the experiment, which sort of give you statistical significance, eligibility for statistical significance. So I think we use some of those, like we use some of the methods to sort of make sure that we're getting enough samples and so on. But again, I think in the spirit of running cheaper experiments and doing faster cycles, I think the way we set up our experiments has a lot of bearing in this, right? And sometimes it's a constant debate. Look, this costs us more, but the return is not so much. Should we even try this? Like, should we do something suboptimal? And so on and so forth. Like, this is a constant debate. And one of the challenges also, should we run longer experiments, right? So I think currently where we are at, we've left it at, there is a general guideline of if your experiment is running for more than 2 weeks, it's a smell, there's something is not right. But we have run more than 2 weeks experiments in certain scenarios, right? So it's not like we'll stop it, but it should be an alarm there saying, okay, something is wrong, or should I look at something more, and so on, right? So I don't think we have a fixed timeline, whatever. I think we follow this general guideline of an experiment should not go overboard and beyond 2 weeks.
Okay. Interesting. Fine. I think so. My next question would be like, what do you look for in a candidate? You talked about you have put together a really good team of like really intelligent people. So what do you look for in a candidate who has applied for this position of data analyst or data scientist?
So let me probably talk about what we don't look for, right? Like, we're not interested in how many algorithms or what algorithms you run. Like, I mean, sure. I mean, if you know all kinds of learning algorithms, good for you. Like, we really appreciate the fact that you have the time, patience, and energy through this. Like, great. We love it. But I think what we look for are like a few of these things, right? So firstly, you've got to be curious. As a data scientist, you're the drill bit, right? And being a drill bit means taking a lot of heat. And if you're not curious, you will not be self-driven, and you can't take that heat otherwise, right? So if you're not curious about what is going on, why is it happening the way it is happening, and so on and so forth, and if you want constantly for someone to be telling you, I should be doing this versus that, not effective, right? So curiosity replaces nothing. I mean, you might know 100 algorithms, not curious. Sorry. Curiosity is not about, I want to understand or learn an algorithm. Curiosity is more about, how does this problem work? Can I think about the problem in a different way, right? Can I appreciate the constraints of the problem? Can I appreciate constraints of the solution, and so on and so forth, right? So this is not about, curiosity doesn't mean like I know 20,000 methods. Right? So, I mean, we are at an information age where click of a button, if you know the higher order concept, you will get the details of the methods, right? While it might be slightly inefficient, we are happy to take that learning and onboard that inefficiency rather than lack of curiosity on problem, thinking about the problems, breaking down the problem, thinking about constraints of the problem, and so on. So the biggest thing that we look for is that curiosity of how do you think about the problem? Do you think about it holistically and what? The second thing that we look for is how is your fundamentals? So as a data scientist, one of the expectations, at least that we have at Rapido, is you are the master explainer. Like, you're able to tell a story which is not just understood by your fellow data scientists or analysts or product people, but it is also understood by people who don't have anything to do with this. Like whether it's people on the city team, people in ops, marketing, whatever it is. So the idea behind a data scientist being able to explain and tell a story is to also make some of the analysis more palatable for anyone who is sort of coming into this process, right? I think what we've observed, at least in my past experiences, explainability improves trust whenever you're building operational levers, etc. Whenever it becomes a black box, the trust, gaining trust takes time, takes more time, and is harder to sort of push through, right? So you need a certain level of expertise to appreciate the black boxness rather than the explainability of why the way it is. And given most logical things can be explained in some fashion, right? So that's the second. Like, you should be able to, you should have a core fundamental which allows you to explain why are things happening the way they are, right? The third thing that we look for is a lot of patience and being able to skim through a lot of data. If you're not interested in looking at data and you're only interested in modeling, when I say modeling, like you're only interested in creating a model, I don't think you'll look at it, right? So I think you should genuinely be interested in looking at correlations, looking at all kinds of slice and dice, looking at things like, will aggregation change? Will I have to look at a different PDF and so on and so forth. Like just being able to spend a lot of time and have patience to spend a lot of time with that, I think is another fundamental quality characteristic that we look at. The reason why I call out these things is if you use something like an H2O or any other online modeling, like the dynamic and ML engineer modeling methods, like the tools, etc., they can do half the job which I just described, right? The reason why we need data scientists or data analysts is because, okay, that job is done. What does that mean? Like, how is it applicable? What is working? What is not working? I think that is the job, right? So the job is no more, how do I build a model? I think building models nowadays is a bit, it's a bit like saying I build a compiler or whatever, right? It's fine. It's the things have standardized. There are some, tweaks here and there, etc. But I think at least in our stage where we are right now, learnings and being able to explain and being curious and looking at a problem differently, etc. That is what we value more, rather than just having an understanding of an algorithm, right? So if you ask me if you're applying for Rapido, this is what you would have gone through. If you have to the interview process.
Yeah, hopefully that would be of value to many more candidates who are looking at this. Yeah, and one other question that I have is again very controversial. So how much does a degree play a role in the shortlisting process?
So I think one of the things that we encourage at Rapido. So if you look at our data science team, they come from varied backgrounds. If you look at our the data product team, again, people are from varied backgrounds. Some of them are ex-data scientists. Some of them are like people who run a business. There is a tech lead in there. This is the product group. Very similarly, in the data science group, there are very core statistical background people. There was a developer and there's a quants guy and so on and so forth, right? So I think from an education and an experience point of view, we are less uptight about it, if I have to call it so, right? So like, okay, if you're an engineer and then you have an analytical mind and you have a strong fundamental, I think you're okay. I don't have an issue. Very similarly, we've done some other course or degree or whatever, that should still be okay. I think what we prefer is some proof of having a strong statistical fundamentals, right? So while our assignment acts like a proxy, there is only so much you can assess through one problem, right? So you should have some showcasing. Look, I have a statistical incline, I have an analytical mind, and I know the fundamentals of how to solve a problem using data, right? So I think that's what we focus on. So education, it tends to act like a proxy. Like if you have done MS in computer science and statistics or whatever, like it tends to act like that proxy of, look, I know some things. I don't just lying or whatever. I think that's the only purpose education sort of like the qualification sort of gives us. But it's definitely not, shall we say, replacement for having analytical mind, having a statistical incline, and so on and so forth. So I think we have had instances where we have rejected MS candidates, and we have data scientists who have nowhere ever been in any kind of a statistical heavy course, right? So we have engineers who picked this up and done it on their own. Like I think we have both examples. So the way I would look at education is it's an indicator, it's a proxy for something. We just use it as that. It is not a hard and stop rule or boundary.
Okay, that's good. And I want to know, like, before Rapido, you were also, you were working for a service-based company, if I'm not wrong. So is there a difference in the incorporation of data science in a service-based company as compared to a product-based company?
Yeah, I think one of the reasons why I wanted to sort of come to Rapido was also to prove that point, I suppose. I think service-based companies, there's nothing wrong. I think they have very similar opportunities. In fact, there are more opportunities there working at different parts of the business, different kinds of businesses with different levels of intensity of problems and whatnot. I think the only difference I see is as a leader there, a lot of the time went in convincing people that they should look at metrics. They should consider these experiment-driven approaches and so on and so forth. Given the nature of organization and the nature of engagements and so on, a lot of the energy was just spent in that rather than doing it. Right. So the only difference I see, at least personally, the only difference I see is there I was convincing about doing something. Here I'm actually doing something and then figuring out, what are the repercussions. I think that's the only difference. Otherwise, I think service industry currently, given the demand for solving a lot of data-centric problems, there's immense opportunities across the board. It doesn't technically it doesn't matter where you are. I think the only advantage you will have in a product-based setup is if you have a right leader and a right philosophy and a right team, you might be able to do a lot of these experiment-centric things and a lot more data-driven products and so on.
I think one probable reason could be that you said that that company was maybe very tightly organized. Okay, so that's why you had to put in a lot of work to convince people to do something, and you're at a startup now where you have a lot more flexibility to take up and think more in an entrepreneurial fashion. So that probably could be one of the reasons why you actually don't have to work so much to convince people to do something or look at a few set of metrics. And then, again, great. So my next round is the rapid fire round where I'll just throw some really quick questions and you just have to answer like within, like, let's say 5 seconds. So, great, let's go. First question, R or Python or SQL?
I think this is controversial. So I would say Python, given my background or whatever.
Okay. One thing you love about working at Rapido?
The hustle, like the constant numbers and hustle.
Okay. And one thing you would like to change about Rapido?
I think we could become slightly more empathetic towards a lot of things. Like, I mean, this is not this is a constructive criticism where we're extremely metrics driven, right? Like, we have like almost all conversations are numbers, right?
Okay.
Even a lot of empathetic things happen through numbers, which is good and bad. So I think we can be a lot more empathetic about how customers feel, how captains feel, and there is a lot of that empathy already, right? Like one of the fundamental things about both like what founders have done and like what the current leadership is doing, etc. Like all of us constantly talk about, hey, do we have a voice of the customer? Do we know what the captain wants, and so on and so forth. But I think we can do a lot better. I think the bar is, at least from my point of view, the bar is slightly more higher, and I think we can get there.
Okay. The go-to learning resource that you advise every incoming junior at Rapido to learn from?
Sorry, say that again. What was the first bit?
Go-to learning resources that you advise any incoming data scientist or analyst.
Right. So I think currently the edutech and like a lot of the online information systems, like the way they've grown, there's so many of them. But I would always definitely advise anyone who's trying to do something in ML, AI, like Andrew Ng is a great place to start.
Okay.
He's also one of the master explainers. Like he's able to explain a lot of things, etc. He was one of the first people who probably started the AI ML org and started doing online courses back in 2012. And there are also a few classic books. Peter Norvig, Sebastian Thrun. There's a 3-author book on artificial intelligence. It's like this fact. Talks about a lot of cool things and talks about a lot more fundamental stuff. Like I think currently, if you look at the AI narrative, it is almost always about machine learning. I would recommend aspirants, even students, start with that book. It's slightly dry, but it opens your like thinking up for a lot more ways of thinking about how to do fuzzy, right? How to do
Yeah.
intelligence in general, right? So again, it's a dry book, caveats
Okay.
added, but definitely a good place to start. Apart from those, I think there are so many courses. University of John Hopkins has a lot of courses. Florida has a lot of courses. Stanford and
Okay.
others have also started. MIT has started. Like there's so many things going on. I think there's no dearth for learning whatever. I think if you ask me personally, what are the two things that I would do in
Yeah.
science, etc. I think these two for sure. In addition to, I think there's a good online community on Data Science Central and KD
Yeah.
Nuggets. I don't know
Yeah.
if you guys have
Yeah.
KD Nuggets are pretty old now. I think they're also fantastic resource to just learn from others. Like while this is learning theoretical and fundamentals, just learning from others, those might be really great places to start.
So machine learning or core statistical experiment design, which would you prefer to master?
Is there a third option of don't care but master all? I think like
Sure,
the
that
way
could be an answer.
like the way I would look at it is I think it's the right tool for the right job. As long as you
Yeah.
know the tool, it should be okay.
Okay. So if you were to start learning data science all over again, which part of the learning process would you change? Your journey.
So my journey. Okay, so I think I started the other way around. I think that's why I have an appreciation of why you should do fundamentals first.
Mm-hmm.
So I started in a lab which had nothing to do with statistics or whatever. We started applying machine learning even without knowing a lot of the basics. I think I had to learn basics as a consequence of not understanding what is going on. Right?
Okay.
Quite honestly.
Yeah.
So because like the way I think and the way I solve and the way I learn is more ground up and fundamentals first. I had to go pick that up and then I realized, oh shit, there's so much to learn and do. If I were to change that, maybe I would do it the other way around. I don't know. Because I did the fundamentals anyway. Maybe if I had
Okay.
the fundamentals, I would run better at the lab that we were trying to run.
Okay.
Maybe that's a thing.
Okay. Okay. So that's it. One last question before we end this call. So, do you have any parting message for an aspiring data scientist or any data professional in general? Like, what should they focus on? Anything that you could provide? Any message?
I think I would repeat what I said earlier. Like, there
Yeah.
is no replacement for being curious, right?
Okay.
The day you stop being curious, the day you will become a less successful data scientist or any data
Yeah.
centric profession.
Okay.
Personally. So there is no replacement for being curious. And being curious does not mean, again, methods, being curious about problems themselves, constraints of the problem, solutions, constraints of the solutions, and so on. Right? There's absolutely no replacement for that. If you ask me, how do I become curious? I am not a good teacher when it comes to these things, but being curious definitely helps. There's a massive correlation between some of the successful data scientists to how curious they are about problems and solutions.
Great. Well, thank you so much, Pramod, for connecting today. And I hope, and I'm sure, like this would be an enriching conversation for people who would be watching this. So, thank you so much.
No problem. It was a pleasure being here. I'm sorry about some of the network-related things,
It's
but
okay.
it was a great conversation. Thanks for that.
All right.